All right, hey guys, we're gonna do amino acid, what would you call it, like transmodulation. Amino acids into other amino acids. So, this one I'm gonna let you know is a slightly different technique, and is, so just know that going in, and know that there are some holes in this particular mind map, or whatever. Mind map means something else too, but you know what I mean. So, picture yourself in your favorite class, your favorite place, class. All right, so at the front of class, you can see, that whiteboard that's on the left, and then the middle that's got the screen, and the whiteboard on the right. And then behind you, there's a whiteboard back and to the right, and a whiteboard back and to the left. And then there's the whiteboard right next to the door on the way out. So on the left side, before you're going out, there's a whiteboard there. It's the back left whiteboard, but still on the side wall. That makes sense? Okay, and then there's the door. And then outside the door, there's the hallway. And then there's going down the hallway to the stairs. And then there's going up the stairs to the second floor, which is where we are right now. And then at the top of the second floor. Okay, all of those places I just named are locations in this actual, more like a stereotypical memory palace. And I decided to try that out this time, and that's how I memorized it. And it worked, but man, it was a lot of information. So, here we go. Our first step, that front left whiteboard in front of it, okay? First, there's a little, and I'm not going to try and write this out because this is try and see it in your head and make a memory palace. Feel free to do it another way and take down the information and do whatever you want with it. So, in front of this front left whiteboard, there is a little pile of glue. And so this is glutamate. And so if you watched the other video where you were here, then that's what I was doing like this. That's glutamate. All right. So that's there. And then glutamate can become glutamine by adding just another amino group. Okay? And so I have a little pile of glue, and then I have a huge mound of glue. And that reminds me, okay, the first one was what? Glutamate. The second one has got to be glutamine, because it's a pile of glue. And it reminds me of both of those. And then below those, I see a little alpha symbol. And I personally think the Greek symbols are just cool. And so, excuse me, that's what I thought. Love to have spam calls. So, alpha ketoglutarate. I see the alpha symbol, and I just see it kind of coming out of the floor in a three-dimensional kind of way, like it's been engraved or embossed out of the floor. It's like, all right? So those are the three things at the front left whiteboard. Okay? Now, shifting to the screen, below the screen, we see two donkeys. Another word for donkey is ass. So there's aspartate and then asparagine. And one of the donkeys is a small donkey, aspartate, and one of them is a huge donkey, asparagine. Okay? And then below those donkeys, well, let's keep all of the animals together. We have an ox, oxaloacetate. Okay? So donkey, donkey, ox. And as you're shifting from position to position, just to make it clear, right now, we are only looking below the screen. We have completely forgotten about the first one. If you try and have any more in your head at once, it's going to overflow. At least for me. And if you can do it, great. But clear barriers makes chunks useful. No barriers means chunks is not a real thing. It's not actually a chunk. It's a mire. Yeah. So shifting to the third thing. All right, we're actually going over here, and we're on the front right whiteboard. Now, oh, and by the way, so far, you'll notice we've had some amino acids, and then we've had what they degrade down into like the TCA cycle sort of area. So those are the two things that we're trying to hit most of the time. And then when diseases come in, those are the third things. It's like, was there a disease here? What does it go to in the TCA cycle? What other amino acids are going to? That's what we're trying to identify here, just to make it super clear what's supposed to be in this map. That'll remind you to remember if there's like, was there a disease? Oh, yeah, okay. So, front right, there are two. So how many of you know Weird Al? Great. I love this place. All right, so I'm just so nerdy. All right, so reputation gone forever. So he represents alanine, okay, Al. And so I see him with his characteristic curly locks. And he is cooking a pie in like this cast iron stove or whatever, like just a pan, okay? So he's got a pie that he's cooking, and that's because he goes down into pyruvate, okay? And then there's also serine. And how do you remember that? Because he is searing, that's why he's cooking, he's searing the pie, okay? So serine is there, alanine is there, serine turning into pyruvate, double check, but I'm pretty sure that it does. This is one of the ones that do double check me. So, with serine, there is a disease. And it is one where, okay, so serine, okay, we're getting that. Serine also has, let's see, there's 3 phosphates on the edge of that, on that cast iron. So on the edge of the cast iron, I did this later. Anyway, there are 3 beads of phosphate that just look like little green orbs that I've stuck on the side of the pan. There's 3 of them, they have a yellow P on them, and they're just right there. So it's 3 phosphates. So serine comes from something that has 3-phosphoglycerate. That's right, it was in the glycolysis pathway. So, and then above that, so above the pie pan, I see this child's head, and he has some mental retardation. He's very happy, and we saw a picture of him during the slide set, and I would encourage you to go look at that. And I just have hit that face, which stood out to me, hovering above the serine. Because if you don't have enough serine, you're going to have that issue where, especially during development, you're going to end up with mild mental issues, and you're going to be happy. Generally speaking, they tend to be very happy individuals, even though they have other things going on. Okay? What is that disease called? Great question. Let me know. So, moving on from the serine, we have, okay, we're back down to the pie pan. Hopefully you can see that where he's cooking it. There is something that leads off to the corner, further beyond, like the front right corner, okay? There is a bushel of leaves that's just a little bit to the right, and that bushel of leaves, they're dark and leafy. Where do we get folate? Dark leafy greens, okay? So that represents, and there's like a line going over it from the pie pan to where we're headed, and that's because folate is required for this pathway to happen. So you just see a line going over it. Then over there, once you have folate affect serine, okay, so it's coming from the serine, then you get to glycine. Yes, and there's a glider there. And the glider, yes, we like the glider. It's nice and easy, okay? And, by the way, normally, after each of these chunks, like the first board, the second board, the third board, review the new chunk and the chunk before it. We're not doing that right now. This is just FYI, okay? And every 4-ish chunks go from the beginning to the end. So, or at least halfway. Now, from the glycine, you also have some incense just like tucked up right in the corner. And the incense has some pink fumes going up, if you can just see those. Yeah. So, that is fumarate, okay? And that is in the TCA cycle. Okay, so glycine can go to fumarate. Glycine can also be made, Ginger, you might remember this one. In another one of my memory things, I don't remember if I posted this one, there was a wheel in the urea cycle on the front of a trike, like a motorized trike. And it represented NH3, ammonia. Okay? And so if you have ammonia, if you want to use, so for me, I used the wheel because I had already used it before, and I had that up there. And so you can also make glycine just from raw parts, because literally glycine is the amino acid backbone and a hydrogen. So you just make the backbone with amino group. So if the wheel doesn't work for you, which it probably doesn't for most people, just stick a steak. I mean, it's got amino acids. So There you go.
I think we used the steak.
Oh.
I remember the steak more than a wheel.
Use the steak, it's
Yeah.
tastier. Unless I cook it and then it tastes like the wheel. So, great. So that's all of what we have on that side. Now we get to go, phew. I would recommend having that all be just one chunk and, like, not one chunk, like the 4 separate chunks. Cut off, make that a single review thing, and now we're going to do another thing and have it be part of a different review cycle instead of trying to go through this huge thing all at once, which I found out you can, yeah, unless you're really good at dropping stuff beforehand, it can start to build up. Anyway, back right board. On the back right board, for those of you who like chemistry, we have a phenyl group. For those of you who don't like chemistry, we have phenylalanine, and it has this. It's I can't draw it, but it's a ring. And to remember phenylalanine, you can either have a phenyl group or you can have a funnel. Okay. So you have a funnel at the top, probably. So just the funnel represents, oh, we're talking about phenylalanine now, okay? And there's a funnel, like, taped to the board. Phenylalanine, now, for this one, I am going to go ahead and draw a couple things. So, if you can remember the overall shape of what I'm drawing, then that should remind you, oh, there's a thing there. There's a thing there. So we have a line that goes down here. There's a thing here. We have a line that goes down to here, and then over here. There's a thing there. And then we have something going over here. There's a thing there. And we need an enzyme at each of these lines and a disease. Okay? So, right here, and so really it's kind of focused on one line at a time, and then that makes so that it's okay. So they're kind of like mini chunks. All right. So right here, we have the enzyme phenylalanine. See, and that's, I always look at the thing we're coming from because it helps so much with the names. Phenylalanine, I don't know if this is dark enough anymore. I'm looking, and you guys are probably like, I can't see anything. All right. All right, so we have Phenylalanine Hydroxylase. And I just put A for alanine because I got really lazy. Hydroxylase. I'm not sure you guys can read what I'm writing anyway, so. Now, if this enzyme is broken, we're going to have a number of diseases on this one. If this enzyme is broken, obviously something's going to go wrong. Well, what's going to go wrong? It's going to be phenylketonuria. Okay, so phenyl, obviously, because, you know, the phenyl group, right? Keto, because a ketone looks like this, right? Ketone is a double bond O in the middle of a group. If you're familiar with ketones, you're happy. If you're not, then this will make you more familiar with ketones, which will be good for you. So, I just have a ketone that pops up when I'm looking at this enzyme. It's like phenyl. I know I had something to remind me what this thing's called. Oh, I was that ketone group. Oh, phenylketonuria. So whenever I'm struggling with the name of the disease, not that you have to struggle with the name of the disease, then you're like, I know I had a reminder. The ketone group will pop up, and it'll just be that picture, urea. Okay, phenylketonuria. Check. All right. Next, we have, this becomes tyrosine. So this little spot is tyrosine, and you can leave the circle. It's just, I was trying to. Anyway, so obviously now we know that phenylalanine can become tyrosine, right? So that's an important thing to note. Tyrosine. Tyrosine wants to go this way using a tyrosine transaminase. So it's that thing, transaminase. And this, if this one's broken, then you're going to have albinism, because this is what makes melanin, which is, you know, the skin color thing. And so if this is broken, you don't get melanin, you have albinism, which is when you have white hair and no skin pigment and you're very, very white, but not necessarily nerdy. Okay.
I have a friend who's an albino.
Oh yeah?
Mm.
Cool. All right. And then tyrosinase. You know what? This one is tyrosinase. Tyrosinase. And this one is trans. Tyrosine transaminase. Right, this one's tyrosinemia. Yeah, tyrosine transaminase. So this one was, tyrosine, albinism is tyrosinase, and albinism, they're both roughly the same length, is the double check that I have. The word albinism and tyrosinase, they're both roughly the same length. And so with that one, I have to do my double check sometimes. And I always do my double check when I come over here, apparently, even when I'm teaching other people. So when you have something that you notice that you're like, oh, that's slipping, stick a double check in if you've got enough mental room, or if you're desperate and hope it sticks. I was desperate. So this one, tyrosine transaminase, if it's broken, is going to give you tyrosinemia, which is really easy because it's just tyrosine problems. Tyrosinemia. Tyrosine in the blood, emia. Synemia. I don't know why I'm writing these. I know no one can read them. All right. Yeah, especially with the lighting. All right. So we've got that one done, that one done, that one done, and then down here we have a picture of, let me pull up the picture, genes, sick, homogeneistic, homogene sick. It's got homo, it's got gene, and it's got sick. It's probably homogenistic. I know it well enough that when I see the word, it works. I know I don't have it perfectly. I warned you guys. You have to put up with my stuff. So right here, I have homo can also mean like single, and so I have a single human. And then I have gene, which is then genes. So someone's wearing jeans. And then sick. They are sick, as in, they have the flu. So, jeans, I see denim. All right, this person is wearing denim jeans, and they are sick. Okay? And this one, the disease, if this, oxidase. And you remember oxidase, because we're talking about an enzyme. So clearly, that something has an A has to have an ACE, and I remember that there's an O2 down here, and it just sort of hovers, and it reminds me. All right. I told you there's a lot of stuff. Just remember one part at a time. All right? And what happens when this thing's broken? It's the disease that I like, because it's just, for me, it was like a free name. Every now and then you have a golden brick that just fits itself in. Alkapnuria. Alkapnuria. All right, we already had a urea. We already had a urea disease up here. Phenylketonuria. Well, now we start with a urea. We end with urea. Okay? That's my double check. We have phenylketonuria and we have alkapnuria. And it helps if you say them. I made that mistake with the homogenistic or whatever the heck. I didn't ever say it. So it's dead. All right. Let's see. K-ora. All right. Yep, we're pretty close to out of time. I'll tell you what the rest of the things are that we didn't hit. We didn't hit methionine with its SAM, which then goes, SAM is something that donates methyl groups, and it has a cysteine, not cysteine, anyway, methionine, do methionine, then you have cysteine, then you have arginine, then you have histidine, then you have proline, he's a pro runner, and then you have threonine going up the stairs, and then you have the branched amino acids, which I will do super fast, valine, leucine, and isoleucine. And I have a sucker, there's a huge tree because they're branched amino acids. At the top of the stairs, there's a huge tree. There's 3 big branches. You have valine, leucine, and isoleucine. And from those 2 branches, the valine and isoleucine branches, there's a sucker hanging down because they go to succinate. And then the middle one doesn't have a sucker because leucine is the one that doesn't do glucogenesis or whatever, gluconeogenesis. And so it doesn't get a sucker. It obviously isn't, there's no sucker, it doesn't go to succinate. So, and those 3 also have maple syrup disease, BC-KAD, BC-CAD. I see a prehistoric person who is a CAD, BC, prehistoric, yeah.
Gotcha.
And maple syrup disease, he's looking down at maple syrup urine disease. He's looking down at, oops, and it's all maple syrup. So, those are the branched amino acids. That's actually the one that sticks with me, so I wanted to give you that at least. The histamine's a snake that goes, and it's got histamine above it. All right. See you guys. Sorry we're out of time. Hopefully this helps, and catch you next time.